Hello, everyone. My name is Reza Hadi Mogavi, and I'm a PhD student at the Hong Kong University of Science and Technology. Today, I'd like to share with you our recent work on characterizing student engagement moods for dropout prediction in question pool websites. This article is co-authored by Dr. Xiaojuan Ma and Dr. Pan Hui. Online education is growing very fast. We have many MOOC platforms like Coursera, edX, and ShueTangX. We have Q&A communities like Chegg, Course Hero, and Stack Overflow. We also have question pool websites like LeetCode, GoldChef, and Math Playground, which are often used for learning and practicing more hands-on type of courses. However, they are sadly often understudied. But in this presentation and in this paper, the focus will be on the question pool websites, of course. What do question pool websites or QPs do? Well, they support problem-based learning or PBL. And if you are familiar with active learning pedagogies, PBL is a learning style that results from the process of solving challenging questions. This way, you can gain knowledge, and this is very important. But do students really engage? Empirical findings suggest that 40% to 80% of students registered in QPs drop out in less than 2 months from their registration. It's very soon. Dropout means that these students' rate of activities or problem solving dropped to less than 20% of what it was in the first month, and that's shocking. But why is that so? Why do students drop out so early, and why can't QPs hook students for an extended period of time, or even turn them to lifelong users or learners? To find the answers, there's a strong need to know the QP students better. Why do they engage with these platforms in the first place? But before getting there, we need to clarify engagement a little bit better. There are various conceptualizations of engagement in the HCI community. The three most widely utilized conceptualizations include behavioral, cognitive, and emotional engagement. In an informal way, behavioral engagement refers to the activities people do and their participation. Cognitive engagement refers to the mental processes, and emotional engagement refers to the affective responses. But since it's often time-consuming, costly, and in some cases impractical to get every student's affective response to educational platforms, especially at large scales, we restrict our work to quantitatively measurable engagement aspects to run our analysis. And that means we only use behavioral and cognitive engagement for the purpose of this paper. Now that we have defined engagement, we can formally organize our research using 3 questions. What are student engagement moods in QPs? How are these engagement moods and dropout rates correlated? And can we use student engagement moods to predict the student dropouts more precisely? To answer our questions, we study a large-scale QP from China as a case study. The platform belongs to Hangzhou Dianzi University's ACM team and on average hosts more than 100 students every day and receives more than 300K programming code submissions every month. In summary, our data is comprised of almost 10K students in a time range between January 25th to July 15th, 2019. And the number of dropped students is approximately 5,000. So, as we mentioned, engagement is really the key to this research. And we use clustering analysis with an unsupervised method to capture and characterize students' engagement. More precisely, we use an unsupervised hidden Markov model, or HMM, for characterizing and decoding of QP students' engagement moods. The reason we use HMM is that we really cannot see every aspect of behavioral and cognitive engagement of students. Some we can see, we call them manifest features, and some we simply cannot. Those are hidden. The manifest features come from the literature: performance, challenge, endurance, and attendance gap. The first 2 are signals of cognitive engagement. The second 2 are signals for behavioral engagement. The question here is, can we find clusters of user engagement based on what we can see? To this end, we use AIC and BIC measures to find the simplest, most descriptive model for clustering students' engagement moods. We find that there are estimately 5 distinctive underlying hidden states or engagement moods that generate and distinct the observable behavioral and cognitive engagement signals. But what do these 5 states mean? We run a comprehensive feature analysis to characterize the hidden states resolved. However, the engagement moods are visually illustrated better if we describe them through the frequency plots of student submissions over different question IDs. The larger the question ID, the more difficult the question usually becomes. As you can see, challenge seekers often look for more challenging questions. Subject seekers are interested in specific topics. Each of these spikes. For example, some of them are interested in graph algorithms. Some of them are interested in maybe basic data structures. And they are distinguished based on different topics they search for. Interested seekers invest equal amount of effort on different topics. Joy seekers are a little bit playful. As you can see, they submit repetitive solutions to the same question again and again. And in some sense, they are seeming to abuse the system. And then we have non-seekers who have tiny participation in the system. They usually come for a short visit and just go. However, at this point, these are just computational estimations and clusters. The acid test question is, are we on the same page with the students? Are these characterizations reasonable? To this end, we conduct an experience sampling study with 26 local students to evaluate our characterizations. We notice that there is a 76% agreement between the engagement mood labels extracted from the HMM and ESM, experience sampling method. This is more than 50% better than a random labeler with an accuracy of 20%. The table below shows the summary of the responses from different users. But what about the second and third question? To answer RQ2, we decided to run a correlation analysis to see how the student engagement moods are correlated with the student dropouts. Do students in each engagement mood have any collective preference for answering questions? The answer is yes. There is often a distinctive likelihood for each question to get answered when students are in different engagement moods. When students answer questions that are not suitable for their engagement mood, we find that their probability of dropping out also increases accordingly. With this knowledge in mind, can we now predict students' dropout more precisely? To answer this question, we run a comprehensive ablation study with different features and different classifiers. In summary, we find that whenever we add the engagement features to our classifiers, then we can do a better prediction task for dropouts. But whenever we don't have those engagement features, the performance is a little bit weaker. And this is interesting. But what are our main findings? To the best of our knowledge, we are the first research to characterize different student engagement moods for a large-scale QP website. We find that students have collective preferences for answering questions in each engagement mood, and deviation from those preferences increases their probability of dropping out significantly. Finally, according to our findings, adding the student engagement moods can, of course, robustly improve our predictions of student dropouts. In conclusion, our work has 2 main contributions. This research helps customize user experience in QPs, and it also can be used to manage student dropouts more accurately and strategically. However, we believe there's still a long path in front of HCI and CSCW researchers to fully explore and understand student engagement and dropouts on different educational platforms. Cross-validation of our work on other QPs and similar educational platforms, finding more personalized engagement moods, finding ways to automatically capture students' emotional engagement moods and include them in analysis is another interesting direction to go. In the end, I'd like to sincerely thank you all for your time and kind attention.